Hi, this is Jack Nyland, and today we're going to take a look at solving problems involving polynomials. Suppose we had to solve a problem where we were given a rectangular prism with the dimensions of x minus 1, x, and x plus 5, and told that the volume was 48. What are the lengths of each of those sides? Can we figure it out? We can form an equation, x minus 1 times x plus 5 equals 48, because we know the length times the width times the height equals the volume. And when we multiply that out, we get the polynomial x cubed plus 4x squared minus 5x equals 48. Subtract the 48 from both sides, and now we have a polynomial where we could try to find the value for x, which will make this 0. One way we can do this is to try to find a binomial that will divide evenly into it. So we know from our factor theorem that it's going to be the factors of our constant divided by the factors of the highest power of x, 1. So in this case, we have 1, 2, 3, 4, 6, 8, 12, 24, and 48 as the possible answers. And we don't have to worry about the negative numbers because we're going for a measurement, which is going to be a positive number. So if we want to find out if the 1 is what x is equal to, we're going to use x minus 1 and divide it in there with synthetic division to see if it works. Because if it's x minus 1 and we solve that, then x will be 1. So we divide that in there. We bring down the coefficients, 1, 4, negative 5, negative 48. And we bring the first one down, and then we multiply. We add, and we multiply, and we add, and 1 times 0. We get a negative 48, so we get a remainder. So x minus 1 did not go in evenly. Let's try x minus 2. And we're going to bring that down and multiply, add 6 and 12, 7, 14. It's going to give us negative 34. Once again, the remainder was not 0, so x minus 2 is not a factor. All right, x minus 3. So we get 3, 7, and then we multiply 21, add 16, 3 times 16 is 48, negative 48, and 48, 0. So x minus 3 did go in evenly, and we know that the other factor is going to be x squared plus 7x plus 16. So x squared plus 7x plus 16 times our x minus 3 gives us our polynomial. Now we're going to try to solve this one. And we look at the discriminant first. B squared minus 4 times A times C. And it's negative. So we see that there are no other real solutions. There's only one solution for x, which makes sense. And that solution was 3. And we put 3 into our equation just to check it out. And it does make the 0 equals 0. And when we graph it, we do see that we do have the one solution of x being 0. X is 3 when y is 0, right there. And no other real solutions. So if x is 3, then the sides are going to be 2 and 8. And 2 times 3 times 8 does give us 48. So we've solved our problem. But if you were confronted with a problem like this and you couldn't come up with the equation, you could have always used a table and just substituted values in. So when x was 1, it gave us negative 48, so that's no good. X is 2 gives us negative 34, that's no good. X is 3, it does give us 0, so x being 3 solves the problem. And that'll work for integers. But you can round it and get closer. Even if it's not an integer, you could come close to an answer and get an idea what the answer is just by using a table and substituting. So thank you, and that's solving problems involving polynomials.